Welcome to Found in Space, a science podcast for kids and teens. Today we have a fantastic question. Our question comes from Zayden, and they ask, how can we find exoplanets if they are so far away? So this is just a brilliant question. Thank you for asking this, Zayden. There's a lot for us to discuss here, so let's go ahead and start with the idea of, well, what is an exoplanet? Exo means on the outside of. So you might have heard this with exoskeleton, right? The skeleton that insects have on the outside of their body. Well, an exoplanet is a planet that is outside of our own solar system. Sometimes you'll hear this called an extrasolar planet. And these objects are really, really far away from us. Even in our own solar system, we're talking about hundreds and thousands of kilometers away for our planets. So when you look up in the sky and you see Mars or you see Jupiter or even the moon, they are really far away. But in order to get to exoplanets, we would have to travel for hundreds or thousands of light years, typically. So when we talk about the distance between stars, we use a light year instead of talking about a mile or a kilometer, because these distances are really, really big. And a light year is how far light can travel in a single year. This is about, one light year is about 10 trillion, that's with a T, trillion kilometers, or about 6 trillion miles. So really far distances. And the closest of all the exoplanets that we know of to us is just over 4 light years away. So that's a big distance. Now, given all of this, the fact that we can even find exoplanets is really quite amazing, because planets, although they're big compared to a human, compared to a star, planets are really small. So these are small objects very, very far away. And we have to use some extremely clever techniques to actually be able to find them. So some of the things that we do is, instead of looking to see if we can find the planet itself, like look at the night sky, take a photo, oh, there's a planet, there's not a planet. No, that won't work in most cases. What we need to do is we need to look at the star that this planet is orbiting around. So the first method that we use, this is the most common method, it is called transit. And sometimes you'll hear this called the eclipse method. But in the transit method, what we do to find if a star has a planet orbiting it or many planets orbiting it is we look at how bright the star is. So we take a photo of a patch of the sky, and maybe there's 100, maybe there's 1,000 stars in this patch. And we measure exactly how bright each of those stars is. So how much light do we see? And then we wait and we take another photo. And then we take another and another and another and another and on and on. And we might monitor this whole patch of the sky for maybe a month, or maybe we'll monitor it for longer. So monitor is to be watching, to be looking at it, recording this information. And every time we see how bright that star is, well, then we look for a dip in the brightness. So let's say that the star, it's 100%. And then the brightness goes to 98%. And I'm exaggerating these numbers here. There will be very, very tiny differences. And then it goes back to being 100%. But 5 days later, we see a little dip in brightness. And it goes back to being full brightness. 5 days later, it dips again. Well, what does that tell us? It tells us something is blocking the light of that star, and it's doing it every 5 days. So that means something is orbiting around the star every 5 days. If we only saw it dip once and it never ever did it again, well, then that could have just been a random mistake, or it could have been just a piece of space junk somewhere out in the hundreds of light years between us and that star, and it wasn't a planet. But when it repeats, we know that it's a planet. So we know how close the planet is to the star because of how long it takes for it to go around it, and we know how big the planet is. So we can compare it to planets in our own system. Is that the size of an Earth planet, or is that the size of a Jupiter-like planet? We can even use this to figure out, are there lots of planets? Now, we have to watch for a really long time if we want to find planets that are far away from their star. If we were in another star system looking at our solar system and we wanted to spot Earth, we would have to watch for several years to see Earth pass in front of the sun over and over again for us to know that there was a planet there. Now, the next method has another really fun name. This is called the wobble method. Sometimes you'll hear it called radial velocity. And what this method does is, instead of looking at how bright the star is, it looks at what color the star is. So, when objects that are giving off light, when they move away from the observer, when they move away from us while they are giving off light, that light seems a little bit redder than it would if that object was staying still. And when it's moving towards us, that light looks just a little bit bluer than it would if it was staying still. We call this a red shift or a blue shift. And we can look at how red the light looks or how blue the light looks to see how quickly that object is moving away or towards us. Now, we need to combine this with one more important piece of information. And this is that when planets orbit their stars, they are tugging on their stars. Their gravity is pulling on the star a little bit. Just like the moon's gravity pulls on Earth and creates the tides, well, Earth is pulling on the sun, or Jupiter is pulling on the sun. But you know what? Jupiter pulls a lot more on the sun than Earth does, because Jupiter is a lot more massive. So it pulls a lot, and it causes the star to wobble just a little bit. And this is what we look for. We look for wobbling stars by seeing how much they change in their red and blue light. So if there's an exoplanet going around a star, it's going to pull on that star, and it's going to pull it away from us and make the light of the star look a little redder. And then it's going to pull it towards us, and it's going to look a little bit bluer. So our job is to take images of a whole bunch of stars, just like we did with the transit method, and we look at the exact color of each of those stars. And we take another photo, and another, and another, and another, and we look for the change in color. And if we see it going red, blue, red, blue, red, blue, then we can figure out that there is actually a planet orbiting around it. And actually, if it gets really, really red or really, really blue, then we know that maybe it's not a planet, maybe it's a black hole. But the amount of wobble that the star has can tell us how massive of a planet it is. Okay, so these are our two main methods: transit, so our eclipse method, and our wobble method. We look at how bright it is, or we look at what color it is. And just from that, we can figure out if the star has planets or not. So these are indirect methods. They look at the star, not the planet. Now, sometimes under really, really special conditions, we can actually take real photos of those planets. What we have to do is we have to put a little shield. We look at it with our telescopes because we cannot do this with our own eyes. We take a little shield on our telescope and we put it over the light of the parent star. And that will block out the glare, because there's a lot of glare. That light is really bright coming from the star. And with really, really big telescopes. You can't do this with a backyard telescope. You've got to do it with like one of these huge NASA telescopes. And then we can look at that star and look for the planets orbiting around the star. Now, they won't look like a lot to us. They'll just look like one little point of light because we don't have big enough telescopes yet to really be able to see them with more detail. They'll basically look like little stars going around the other star, but there's still a lot that we can learn from that. So, coming back to your questions, Aiden, we can find exoplanets by studying the stars and how they affect the light and the color of the star. Now, moving into the future, we're building new telescopes. We're building telescopes that are bigger, better, with new advanced technology. Some of them we're sending into space. Some we've done that recently, like the James Webb Space Telescope. We can use that to try to study the exoplanets that we know of. And some of these are even going to help us to find new exoplanets. And maybe we can find closer ones to us. We can find planets that are very different than any sort of planet we know of. My favorite are the lava worlds. These are planets that are made of rock, but they orbit so close to their star that they're just melted all the time. They're just a big ball of lava. And there are other planets that are like mini Neptunes and all sorts of really cool things. So I'm sure we will talk a lot more about exoplanets and the different kinds in the future. But for now, this is a great place to wrap up. Thank you so much, everyone. And as always, if any of you listening have questions that you would like answered on the podcast, please go ahead and send those in to us. If you would like your name included, please include how to pronounce that and what your question is. Really look forward to seeing all of you next time.